Inductor data sheets haven't changed very much over decades. So the existing specifications that we've all grown up with no longer cover new situations. It's a good question about why are we even talking about specifications on such an old component, but they're used in new ways. For example, voltage ratings on inductors are really kind of a new idea. Inductors are talked about in terms of current ratings, but now we're putting voltage ratings on the inductors. One of the things we've been working a lot on lately are new transformers. An exciting and very popular application, very necessary, is isolated bias supplies that are needed to drive new devices like silicon carbide and GaN FETs. You don't really get the benefit of those brand new devices unless you drive them properly. And one requirement is an isolated bias DC to DC converter, and generally that isolation comes from a transformer. And depending on how you optimize that converter, what type of circuits you use, the parameters within the inductors might change. For example, we're seeing a lot of specifications to define the capacitance between primary and secondary, the interwinding capacitance, which for many years was just sort of secondary to the inductance and the leakage inductance. And very much the right performance depends on the circuit and how we balance those. So in a way, it's not just that a new specification or new parameter, we've talked about those for a long time, but how we really design the components and how we balance and optimize those parameters for the new applications is really important. So new specifications and new ways of looking at specifications are absolutely crucial to getting the products right for today's applications. We're talking about making electronics denser. Everything is closer together. One very, very important feature for inductors is how well the magnetic field is in fact shielded. And we talk a lot about what we refer to as molded power inductors now, where the windings are completely enclosed by the core material. Nothing is ever perfectly shielded, but those are an order of magnitude better and quieter than a traditional wire wound on a core style of inductor. So there's a case where just simply the way the inductor is constructed, which is usually more interesting to us than it is to the user, but in this case the user gets a lot of benefits. It doesn't provide so much value to the user to make a small component if they have to then keep that component a large distance away from the other components. They don't get a smaller solution. Well, the way we're building inductors these days, by enclosing them in these magnetic materials, allow extra features, not just to make the inductor smaller, but they're more compatible with surrounding components, therefore really helping to make the customer's end solution better and smaller. In fact, those same inductors have another feature because they're essentially made of core material, some sort of iron or some sort of conductive material. It means they dissipate heat better than traditional inductors. It's much more predictable, much more consistent, and in fact lower. They run cooler, which again helps when we're putting everything very close together. So some simple features that the user might not be aware of are really giving multiple benefits in the end solution. We've already talked about features in inductors and specifications, both new specifications and rebalancing those specifications. Well, to take advantage of that, it's easy to imagine that a traditional data sheet doesn't really provide all the answers. And so tools are very necessary. Coilcraft offers a suite of online design selection and analysis tools under our trade name MAGProR. They're known as the MAGProR tools, and we think they're the leading suite of tools really available in the industry. Some of the ones we really feature that are really very popular are for selecting power inductors and analyzing the AC losses. The user can always look at the data sheet and find out what's the maximum current rating, for example. But the tools allow you to put in the exact switching frequency, the exact current, the exact conditions that the user in fact cares about. The user really doesn't care what we put on the data sheet. The user cares what their circuit requires. And we offer this MAGProR suite of tools that's completely designed with the engineer in mind to get answers based on application-specific inputs. And something that's sometimes overlooked at that, we talk a lot about these tools because it gives engineers confidence to make the right selection right up front. Get it right the first time is the motto of using these. We don't encourage people to simulate things just for the fun of simulating things. There's real value, especially with our tools, where the information provided is based on real data taken. It's not based on a theoretical model. And we suggest that this actually not just gets a better solution, but it gets it in the record time, faster, because the real cycle time improvement is not how many clicks someone requires on the website. An extra couple of clicks takes seconds. But if they get the right answer and select the right part the first time, they build their prototype 1 or 2 times instead of having to guess more and try it over 4 times. Those kind of cycles take weeks or months. A few extra clicks on the website, taking the time to do the analysis right, gets it right the first time or very close, and really everybody wins by that.